Alright, so when talking about radioactive decay, what we're talking about are nuclear reactions. These change an atom of one element into an atom of another. Alright? So this changes the number of protons. Remember, the protons is like the identity of the atom. So if we change the number of protons, we're changing what the atom is. So all these nuclear decay equations show us how to change from one atom into another. So there's 4 different examples we're going to work through, 4 different types of problems you might see. The first example we're going to do is beta decay of carbon-14. Now the way you write these reactions is you start off with writing the standard nuclear notation of your initial isotope. So for this, carbon is C, the mass number is 14, and the atomic number of carbon is 6. Now it's beta decay. So decay, we're going to say this is released. Which means that the particle goes on the right side of the reaction. So after the initial isotope, the standard nuclear notation, the 14,6C, we're going to draw a little arrow, and we're going to draw a beta particle. Now a beta particle is 0, -1, E. Now this can also be written as 0, -1, beta, which is a Greek letter, but I use the E because that's what the SOL uses. Then we need to figure out what our new isotope is. So we're going to do a little bit of algebra to figure out what the numbers are of the new isotope. So if we look at just like the top numbers, we're going to figure out what the top numbers are. So 14, remember an arrow is like an equal sign, equals 0 plus x. Well, x in this case is 14. Top number doesn't change when beta decay occurs. And to figure out the bottom number, we're going to have 6 equals -1 plus x. When we solve for x, we get 7. Well, now we need to figure out the symbol of this new element. Well, we go to the periodic table. We look at the element that has an atomic number of 7, because remember, that's the identity of the element. And that element is nitrogen, which has a symbol N. So this is the whole decay equation for the beta decay of carbon-14. So that's the first type. Next type is alpha decay of polonium-210. First thing we need to do is write the standard nuclear notation of polonium-210. The symbol for polonium is PO. Its mass number is 210. Its atomic number is 84. Well, alpha decay gets released as well. So it goes on the right side of the equation. So we're going to draw our little arrow. Then we're going to write our alpha particle. An alpha decay particle is this, 4,2-He. This also has an alternative symbol, which is 4,2-alpha. Then we need to figure out what our new particle is that was created. Well, the top number, we have 210 equals 4 plus x. X is 206. The mass number goes down by 4. And then the bottom number, we have 84 equals 2 plus x. Therefore, x is 82. The element that has an atomic number of 82 is lead, which is Pb. And this is an example of alpha decay. Alpha decay is the only type of decay that we're going to talk about that changes the mass number. All the other types just change the atomic number. Next type is positron emission of carbon-11. So we're going to write our standard nuclear notation of our initial isotope. Carbon is C. Mass number is 11, because that's what we were told. And the atomic number of carbon is 6. Well, positron emission is also released. So we're going to draw our arrow. A positron is like a beta particle, only instead of a negative one, it's a positive one. So 0, 1 e. And now we need to figure out what our new isotope is. Well, 11 equals 0 plus x. X, therefore, is 11. Top number is not changing. Bottom number, 6 equals 1 plus x. X is 5. So the element that has 5 protons, or an atomic number of 5, is boron, which gets the symbol B. So this is an example of positron emission. One last type of decay problem. Electron capture of aluminum-26. Well, let's write the symbol for aluminum-26. Aluminum is Al. 26 is the mass number. 13 is the atomic number. Now, it's electron capture. So this, instead of being released, is going to be absorbed. So instead of drawing our arrow, we're going to add to the left side of the equation the electron capture particle. An electron capture particle is the same as a beta particle. The only difference is the side of the reaction that it goes on. Now we can draw our arrow and determine what the new element is. 26 plus 0 is 26. 13 plus negative 1 is 12. And this element is magnesium because the atomic number 12 is for magnesium, which is Mg. So that's electron capture. So there are the 4 different types of examples you'll see. The only other type of decay particle is gamma radiation. Now, gamma radiation is not written in equations. Not written in equations. Right? It occurs alongside another type of decay. It's just energy that is released. So what the particle looks like is 0, 0, gamma. So that's the Greek letter gamma, and it has no mass and no atomic number. It's, just energy. All right, so those are the different types of radioactive decay.